Assalamualaikum warahmatullahi wabarakatuh. Today we would like to present our topic, foam injection molding.
So let's look up on the raw material used. We use polypropylene resins in foam injection mold. So as you can see on the diagram, this is the propylene monomers that undergo polymerization with other monomers to create a polypropylene. These polypropylene resins can be formed in pellet, which are solid or powder, but most of it in solid. So these pellets are ranging size from 2 to 5 millimeters. It is spherical and color is milky white. But as you can see on the picture, these are the pellets that have been mixed with master batch color to give different properties and visual appearance of the product itself. So this polymer can be divided into two categories, which are homo and copolymers. Homo means all identical monomers in single chain, but copolymers means it contains two or more different monomers in single chain. This copolymer can be categorized into four, which are block, alternate, gradient, and random polymer. So these two types of polymer have different properties which can give a different product and different abilities of the product itself. So, but in foam injection mold, most of it use copolymers because the copolymers are suited for corrosion resistance and it have high operating temperatures as the machine use heat to inject through the mold. So one of the applications for these polypropylene resins is it can be used in dentists, cosmetics, and food packaging. So the properties of this polypropylene is low density, it is chemical resistance, and the stress cracking resistance is very high.
Next, I will explain the key processing parameters involved in the foam injection molding. The first parameter is temperature, which includes mold temperature, melt and coolant temperature. Melt temperature is important because it melts the polymer and activates the blowing agent. Mold temperature affects the cooling rate and dimensional stability of the final product. The second parameter is pressure, particularly the VP switchover, which control the transition between velocity control and pressure control during injection. Proper pressure control helps regulate gas expansion and foam formation. The third parameter is the gas parameter, which includes forming volume, bubble size, and gas concentration. This parameter influences the cellular structure of the foam and determines the final density and weight of the product. These processing parameters must be carefully controlled because they directly affect product quality. Poor parameter control can cause defects such as warpage, dimensional instability, and uneven foam distribution.
So now we are moving to the next part in machine, which category in 2, which is the injection part. In the injection part, plastic pellets melt inside the heated barrel. A reciprocating screw mixes the molten polymer with gas and builds pressure before injection the polymer gas, the gas mixture into the mold. And now for the mold part is the mixture enters the mold cavity where the gas expands to form a foam structure. Cooling channels then remove heat and solidify the material into the final lightweight product.
Next, how does foam injection molding works? First, material introduction. This is the starting phase where the raw plastic and the foaming or blowing agent are loaded into the machine together. Second, thermal activations. As the machine heated, barrel melts the plastic. The heat activates the blowing agent, forcing it to release gas. This gas gets mixed deeply into the liquid plastic. Third is structure control. The operator carefully balances the machine's speed, which is flow rate, and pressure. This control is what dictates how thick or thin the foam bubble will be, and how evenly they are spread throughout the part. Lastly is core stabilization. Keeping high pressure inside the machine ensures the gas doesn't escape. When injected, it allows the outside of the part to cool into a strong, smooth, solid outer shell, while the inside expands perfectly into a lightweight, structural foam core.
Next, I will explain how the foam injection molding process works. The process starts by feeding plastic pellets into the injection molding machine, where they are heated until they melt. A blowing agent is added to create tiny gas bubble within the molten plastic. The material is then injected into the mold cavity under control pressure. As it fills the mold, the gas expands, forming a lightweight foam core while the outer layer remains solid and smooth. After cooling and solidifying, the molds open and the finished product is ejected. This process produces strong, lightweight component and is widely used in the automotive, electronic, furniture and packaging industries because it reduces material usage and production costs while can maintaining good quality. Now I will explain some of the main benefits of foam injection molding. First, it produces lightweight products by creating a foam core with a strong layer, reducing weight while maintaining strength. Second, it provides material and cost saving because less plastic and low injection pressure are needed, helping reduce production and energy costs. Third, it offers better dimensional stability, minimizing defects such as shrinkage and warping, which improve product quality. Finally, it gives manufacturers greater design flexibility, allowing them to produce more complex and thicker parts without losing structural strength. In conclusion, foam injection molding is an efficient process that reduces weight and cost while improving product quality and design possibilities.
This slide shows some examples of product manufacture using foam injection molding. The first one we have in the furniture industry, where foam injection molding is used to manufacture products such as plastic chair, table, and storage container. The foam structure reduces the product weight, make it easier to move and transport while being strong enough for everyday use. Next is electronic industry, where the process is used to produce laptop casing, printer house, and electronic cover. The lightweight structure can help reduce material usage and product weight while also providing a good surface finish. For automotive industry, foam injection is commonly used for components such as bumper, dashboard part, and interior panel. Reducing the weight of this component can help improve the fuel efficiency and overall vehicle performance. In conclusion, foam injection molding is effective manufacturing process for producing lightweight and yet durable plastic product. It helps reduce material usage and production costs while maintaining good product quality. Due to this advantage, it is widely used in industries such as automotive, electronic, furniture, and packaging. Overall, foam injection molding remains an important technology that supports efficient and sustainable manufacturing.